Good day, everyone. I'm Joel Remorosa Cabanyas, and today I'm going to share and discuss to you a topic from fluid mechanics, which is entitled Streamline and Tube of Flow. In this topic, our objective is to be able to understand what is streamline and tube of flow, and to be able to solve problems related to this topic. So, moving on, what is streamline or tube flow? A streamline is a line drawn in a flowing fluid at any instant of time such that there is no flow across that line. Thus, at a given instant, the velocity of the energy particle on the streamline is in direction tangential to the line. Streamlines are used to provide an indication of the flow pattern in a velocity field. So, if we want to know the flow pattern, we use streamlines or we draw streamlines to detect the flow pattern of a liquid. By considering a number of streamlines, we can obtain a flow pattern for the field. For steady flow, the streamline pattern does not change with time. The relationship between velocity and volume flow is flow m3 per second is equals to velocity meter per second multiplied by cross-sectional area meter squared. As a symbol used are Q for volume flow, V for average velocity, and A for cross-sectional area. So together, if we want to form an equation, it can be written as Q is equals to VA. So, equation A, the mass flow rate is required to be known. For instance, steam flow boiler rate is rated in kilograms per second. To determine the mass flow rate, the mass density of the fluid is incorporated. So, in getting the mass flow rate is equal to velocity multiplied by area multiplied by mass density. So here is an example. Calculate the volume flow in a pipe that is 35 mm diameter and carries the hydraulic oil at 3 m per second. And calculate the mass flow if the oil has relative density of 0.8. So first we need to calculate the volume flow, then the mass flow. So we're going to use the formula we mentioned a while ago. Then substitute the given values. So in order to get the volume flow, we substitute the values, which is we have 3 as a velocity, then we have an area of 35 diameter. So we want 2.88 liters per second. Since we already solved the volume flow, we are going to solve the mass flow. So mass is equals to 2.88 multiplied by 10 minus 3, which is the volume flow. Then multiply it by its relative density. So we have 2.3 kilograms per second as the mass flow. So here's another example. A 25 mm diameter pipe carries water flowing at 87 liters per second. The main pipe divides into two pipes, each 100 mm diameter. Calculate the velocity of the smaller pipes, assuming that the flow in each of the smaller pipe is equal and is half of the main flow. So in order to solve this problem, we are going to substitute the given values in our formula. Since R required in this problem is the velocity, we're going to solve for B. Substituting the given values, 0.087 as the flow of the liquid, divided by 2, which is the two pipes that divide the main pipe. Then equals to B multiplied by 0.1, or the diameter of the pipe. Perform the equation and we get 5.52 meter per second as our velocity. That's it. So moving on. So we have 3 problems here. Try to solve them in your scratch or some papers. Then comment down your answers in the comment section below. That's it. Thank you for watching. Please don't forget to click the subscribe button.